stand on the shoulders of giants. I had heard that expression before, but I must admit I didn't really internalize what it meant until recently when someone asked me a question, and that was, how do you innovate? I understand it's a fair question to ask me. In my career, I've received 24 patents, and that's a fraction of the number of things I've invented, nearly all medical or biomedical devices. And hopefully that's also just a tiny part of the number of ideas that I've generated. After all, that's my job. For most of my career, my job was to come up with and then lead the development of novel technologies. And since joining lung biotechnology in 2016 to continue leading the development of the total artificial lung, my job has been to continue innovating across this space, to come up with new ideas to solve the inevitable roadblocks in research and science, and figure out how to make something that's never been made before. Now, none of these things are done in a vacuum. None. I would hopefully be the last person to say that I invented something from whole cloth. And that is exactly what I want to spend a few minutes talking about right now. Let me back up for a second. All right, the first step to coming up with an idea is to frame the problem. It's true that sometimes you'll come up with a solution and then you'll figure out what problem it solves. But frankly, that's just too often a kludge, and the solution isn't likely to be the one that best fixes the problem. So step one is identify the problem. Really understand what are the fundamental issues that you're dealing with, that you're struggling with. Right? Then you can start to find a solution. You never know where an idea for a solution is going to come from. It can be from something a coworker said in a brainstorming session that you and others then build on until it fleshes out into a great solution. That's frequently the most straightforward. But at least as often, you have to go elsewhere, mentally, to find the solution. What I mean is this. If the solution to a problem already exists in the space of the problem, it might likely seem very obvious. In fact, you probably would have just taken it as the next logical step to try. It might not even occur to you that you're taking a step that is actually extrapolating or getting to someplace new. But if there doesn't seem to be an obvious next step or an obvious solution, then to find the solution, you likely have to look elsewhere. And that's why having the question you need an answer to, the problem that you need a solution for, framed and understood, that's why that's important. Because then you can think about it this way. Once you've framed your problem, what other fields might possibly have dealt with this type of problem before? Maybe you can find a spark, an inspiration, a kernel to a solution from there. Let me give you some examples from my own work. When I was first exploring galvanic vestibular stimulation, figuring out how to stimulate or electrically depress cells from firing an action potential, I read up on what people had done who had worked on stimulating muscles, or heart muscle, because they too wanted to stimulate excitable cells, and in the case of the heart, also possibly delay or avoid a pulse that was building in the heart cells. This way, I knew at least that it was theoretically possible to depress or stimulate an excitable cell. There were still some important leaps to make, including, can we do this through the skin and bone of the head to access the vestibular system? And the much harder problem of, how do we target the specific parts of the vestibular system? That took a whole team not only from Vivonics, the company where I worked, but also the Mayo Clinic to figure out. But at its genesis, the kernel of the solution was available. Here's another example. In working on the artificial lung, which uses an immiscible liquid to oxygenate blood, we reasoned that the study of two immiscible liquids has been explored most extensively by researchers in the field of oil and gas. So we read up on what people who study oil and water have done as a surrogate for our own work with blood, which is watery, but admittedly much more complex than water. And the oxygenated carrier fluid, which, because it doesn't mix with blood, it's like the oil in this scenario. We found some very useful resources on diffusion of small molecules in oil and water mixtures, and we built on that to make great progress on our artificial lung. It wasn't necessarily straightforward, And we made several advances, important advances, in the application of these principles to blood. But this foray into a completely different field, it helped spark some very important ideas. And that's what I mean by stand on the shoulders of giants. Find what other people have already done, have already explored, heck, have already solved, and build on that. But the trick here, a very important part of the process of innovation, is to figure out where to find those giants. What other fields are there that you can explore, to see what you can build on and borrow to apply to your own field? And having the problem framed so that you understand the fundamental principles that you have to work with is key to figuring out what other fields there are that have wrestled with the same or similar fundamentals. And that's how you find the giant standing in another field. And that becomes a very important tool to grow your field by borrowing from these other fields and then building on that knowledge that is newly applied. To extrapolate in your own field, to extend the curve over uncharted waters. Well, the work done by others in similar fields is a way to provide some reinforcement to help you reach your target. Now, one last thing. I use the term giants here because that was the expression as I've heard it. Those people in those other fields, they're just people, like you and like me. To someone else, you are going to be the giant. Imposter syndrome be damned. And also, always read everything you find with a healthy level of skepticism, born of the knowledge that everything published has been written by people who, like us, are flawed. But by finding that development, that research, that kernel of an idea from another field, and building on that in your field, that's a good place to start innovating.